Time travel. I mean, who hasn't dreamed about it, right? But what if it's not just a dream? What if it's actually an engineering problem, just a really, really hard one, waiting for us to solve? We're going to dive into the real hard physics of what it would actually take to journey through time.
So is this all just science fiction, or is it a real problem for science and engineering? For the longest time, it was just stuff you'd see in movies. But now things have changed. Thanks to some seriously mind-bending physics, scientists are actually taking this stuff seriously. The whole conversation is shifting from what if to, well, how?
And you can't talk about time travel without talking about this guy, H.G. Wells. He said, there are really 4 dimensions, 3 which we call the 3 planes of space, and a 4th, time. This was a game changer. He's the one who basically planted the seed in all our minds that time isn't just a clock on the wall. No, it's a dimension, a road, a place you could actually go.
All right, so if we're going to travel down this road, we've got to know the rules of the road, right? We need to understand the arrow of time. What even is time? And why does it feel like it only ever moves forward?
Okay, so there are 2 big ways to think about this. For a long, long time, we were all on Team Newton. He thought time was like an arrow, just flying straight, never changing, same for everyone, everywhere. Super rigid. But then came Albert Einstein, and he just completely blew that idea out of the water. He said, no, time is more like a river. And a river can bend, it can speed up, it can slow down, and that's the key. That flexible, bendy river, that's our way in.
But wait, if it's a river, why does it only seem to flow one way, downstream? Well, it all comes down to one big important word: entropy. It's basically the universe's tendency to get messier over time. Think about it. You drop a glass, it shatters into a million pieces. That's a move from order to disorder. But have you ever seen those pieces just jump back together into a perfect glass? Of course not. That's entropy. And that's why time seems to have a direction. And it's not just one thing. Physicists actually talk about 3 different arrows of time. And what's wild is that for us, they're all pointing in the same direction. You've got the thermodynamic arrow, that's the entropy thing, things getting messier. Then there's the psychological arrow, which is just how our brains work. We remember yesterday, but we don't remember tomorrow. And finally, you've got the cosmological arrow, the fact that the universe itself is expanding. All 3 are pushing us forward.
Okay, let's get practical. Mission 1, a one-way ticket to the future. And listen, this isn't some sci-fi fantasy. This is based on real, proven physics. So, how do we do it? The secret sauce here is a concept from Einstein called time dilation. And it's actually pretty simple, in theory. The faster you move through space, the slower you move through time compared to someone standing still. And this is not just an idea. It's real. We see it every single day. Your phone's GPS, the satellites orbiting Earth are moving so fast that their clocks actually tick a tiny bit slower than ours. We have to constantly correct for that. If we didn't, your map app would send you miles off course within a single day. It's that real. But, and this is a huge but, there's a catch. To make a big jump, a really noticeable one, you have to go fast. And I don't mean fastest jet in the world fast. I mean almost the speed of light. 99.999% of it. Can you even imagine that? That's not just an engineering problem. It's a monumental, maybe impossible challenge for us right now. So let's play this out. How would you actually visit the future? The plan is surprisingly straightforward. Step 1, get in a really, really fast spaceship. Step 2, hit the gas until you're cruising at nearly the speed of light. Step 3, fly around for a bit, then turn around and come home. For you, maybe only a year has passed. But when you land back on Earth, whoa, decades, maybe even centuries could have gone by. You've done it. You've officially traveled to the future. So bottom line on future travel? The theory is rock solid. Physicists all agree. The laws of nature say go for it. The only thing stopping us is us. Our technology just isn't there. We don't have an engine that can do it. At least, not yet. All right, future travel is cool. But let's be honest. This is the one we're all really here for. The round trip. Going backwards. Can we go back and see the Roman Empire? Maybe fix that embarrassing thing you said in high school? Now, this is where things get really weird, really speculative, and yeah, a whole lot more fun. To even start thinking about this, we need to upgrade our physics. We're moving from Einstein's special relativity to his big masterpiece, general relativity. And this is where, as the legendary Stephen Hawking put it, you could potentially warp space-time so much that you could go off in a rocket and return before you set out. Think about that. Bending the fabric of reality itself to create a loop back on itself, a loop that takes you to the past. The most popular candidate for creating one of these loops? The wormhole. You've probably heard of them. It's basically a theoretical shortcut through space-time. The classic analogy is an apple. If you're an ant on one side and you want to get to the other, you can crawl all the way around the outside. Or you could just chew a tunnel straight through the middle. That tunnel, that's your wormhole. A shortcut not just through space, but maybe through time. Okay, so how on earth do you turn a wormhole into a time machine? This is where it gets really trippy, so stick with me. First, you need to somehow create a stable wormhole. Let's say you have the two ends, the mouths, right there in your living room. Now, you grab one mouth, put it on a spaceship, and take it on that same near-light speed trip we talked about earlier. Thanks to time dilation, that moving mouth is now aging slower than the one sitting on your carpet. So when you bring it back and put them next to each other, one mouth is in, say, the year 2050, but the other one is still in 2040. You walk into the 2050 mouth, you pop out the 2040 mouth, you just traveled back in time. So we've looked at the pretty solid science of going forward and the super wild theories about going back. What's the final call? Should we start packing our bags for a trip to the 1920s? Let's break it down on a scorecard. Going to the future, the theory is uncontroversial. It's totally possible according to physics. We just can't build the machine yet. Now going to the past, that's a whole different story. It is highly speculative, requires things like stable wormholes that might not even exist, and it opens up this massive headache of paradoxes. You know, the famous grandfather paradox. If you go back and stop your parents from ever meeting, how were you born to go back in the first place? It kind of breaks your brain. But, you know, maybe we're looking at this all wrong. Einstein, the man who started this whole conversation, left us with this incredible thought. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. What if it's not a road we travel down at all? What if it's all just there and we only experience it as a straight line? Which brings us to one last question for you. If time really is just an illusion, if it's all just one big landscape you could explore, where would you go first? Something to think about. Thanks for coming on this trip with us.